So guys, in previous videos, we discussed how to represent quantitative and qualitative data visually, and we discussed the bar graphs and histograms. So these will be our main ways that we're going to represent our data visually. However, there are some other graphs that could be used, some alternative visual presentations. And in this video, we're gonna go over some of those. And the first one is a stem plot. So let's take a look at what stem plot looks like. I'm not gonna describe it, I'm just gonna do it and you'll see. We'll start by observing this data set. It says the 20 concentrations of aldrin for river Y are given below, and construct a stem plot that displays the concentration of aldrin for river Y. So you can see that there are measurements and that consist of a whole number and a decimal. Right? And the whole numbers are the ones that are repeated values. So to construct a stem plot, we're gonna basically split each data value into two parts. One part we're gonna call a stem, and another part we're gonna call a leaf. So one that so we're gonna the ones are gonna be our stem, and then decimals are going to be our leaves. Okay, so what kind of stems do we have? Well, we have 3, 4, 5, right? So forth, and the highest one is 8. So we're gonna list all of them. So we're gonna have 3, 4, 5, 6, 7, and 8. It's important not to skip any of them. For example, I don't see any values with a stem of 6, but we cannot skip it. Because we are going to observe the shape of the data based on this information. So the first value is 3.4. So we're going to look the row where 3 is a stem, and we're going to put 4 as a leaf in that same row. And then 4.0, we're going to again find the row where 4 is a stem, and we're going to put a 0, the decimal point that corresponds to that 4. So 5.6, 5 is a stem, so we're going to go into this row, and we're gonna list the leaf for it, and we're gonna continue doing it for the rest of our data value. Let's do one more. So here we have 3.7, right? We already had 3.4, so we're going into this row where the stem is 3. Now the other leaf that we have is 7. So we're just gonna list it, this value separated by a comma from the previous value. Okay, so this way, once we're done, we're gonna know exactly how many values we had with the stem 3, how many values we had with the stem 4, with the stem 5, so forth. Okay, and we're gonna see exactly what kind of leaves we have. So all the data is gonna be preserved, and it's just gonna be formatted differently. But looking by the stem and leaf plot, we could restore our original data. Maybe not in the same order. It's gonna be in actually in order, sorted in order, but all the original data is going to be there. So here we go. This is our finished chart, okay? And what I can see from this chart is that the most occurring value is with a stem 4. So it's 4 point something. That's the most occurrent value. The second most occurrent value with stem 5. Stem 8 was also often observed. There are no values with stem 6. Okay, so there's a lot of information that I can draw from this graph, and we're going to discuss how we can use it a little bit later as well. But so this is what stem and leaf plot is. Now, I could also order these values, put these values in order, like make another chart, just put 1, 2, 3, and then I don't have 4, 5, 6, 6, 7, 8, and put these one from smallest to largest, organize it a little bit more. What else can I do? If my one of the rows is too long, what I can do, I can split my stems a little bit more. For example, I could have one stem from 3.0 to 3.4, and the next row from 3.5 to 3.9, and then the next one is 4.0 to 4.4, and the next one is 4.5 to through 4.9, and so forth. But you have to make sure that each stem has the equal number of possible leaves, not actual leaves, because like here we see that 5 has 1, 2, 3, 4, 5 leaves, actual leaves, right? Observed values, but 6 has none. So we're not talking about observed values, but possible. So possible values, leaves for 5, we have 9 of them, right? Actually 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have as many same amount of possible leaves for 6. So that's what I'm talking about. The number of possible leaves should be equal for each stems. That's how you break it up. So here's some notes about stem and leaf plot. Those stem and leaf plots do not work well for large data sets. Number 2, there is no magic numbers of stems to use, but 5 is a good minimum. Too few or too many stems will make it difficult to see the distribution shape. If you decide to split stems, be sure that each stem is assigned an equal number of possible leaf digits. That's what we just talked about. And the last tip, you can get more flexibility by rounding the data so that the final digit after rounding is suitable as a leaf. Do this when the data have too many digits. So for example, what is it talking about? Let me give you an example. Let's say you asked professors about their salary, and so the salary is given as, let's say, 49,725. So that's too many digits. You can round it up to 50,000 and use 5 as a stem and 0 as the leaf in this case, instead of using 4 and then 9,725 as a leaf. So that's what it's talking about. So now using stem plots, they're good in order we could see the shape of the distribution. For example, let's say you want to see the shape of this distribution. All you have to do is turn your stem plot on the side, and you can see like this is going to be a bar. Each column is a bar. So you see the shape of your distribution, just like that. Also, if you want to compare two distributions, you can do the stem plot side by side. So for example, here we have the bowling scores of male and female participants in the finals of a national tournament. So you see the females scores on the right and male scores on the left. They all have common stem, and compared side by side, you could see that the female's average is a little bit higher up, so a lower score around 25, stem 25. The males scores, actually, the majority of them, uh, you know, towards the bottom of the chart. So for around the stems 27 and 28. So I think that the average is going to be somewhere here in this vicinity for males, and the females is going to be about here. So very good for comparison. So let's move on, and another graph that also shows the shape of the distribution very well and still preserves all the original data values in a set is a dot plot. Let's see how to construct a dot plot. And here's, you already seen this data set before. It says, asked students who took my stats course last semester, what is your height in inches rounded to the nearest inch? And I got my result. Let's construct this dot plot. So first what I'm gonna do, I'm gonna draw an x-axis where I could put make sure that all of my heights actually fit into my scale, right? So I think my lowest value was 48 right here, and my highest value is 80. So I'm make sure that I have home for all of these values. And then I'm gonna start putting dots about every value that that I have. I'm gonna mark the fives really just for my convenience, so it was easier for me to start. And so the first value that I have is 67. So I'm gonna put dot above the value of 67. So I have 60 here. This is 65. So 67 must be right here somewhere. So I'm gonna put my first dot there. Okay, then the next value is 59. So 50, 60, 59 is gonna be right here. Next one is 66. This is 65, this is 67, so 66, it's right next to 65. Next is 73. 73 is gonna be right here. Next is 68. Again, did I have 68? No, we had 66. So 68 is gonna be here. Okay, so I'm gonna continue this process. I just want to see that if I encounter a second value, like I just filled in 68, I have another 68, then I'm gonna put a dot above it like this. So the repeated values are gonna go up. So if I have a repeated value, I'm gonna have a column forming there. So I'm gonna continue this process. I'm gonna show you what I got in the end. So this is what I got once I finished. It's a little bit, handmade, so not very perfect, but still I can analyze this data. I can tell that my most frequent value was 71. That's my tallest column. So again, those dots are forming columns. My second frequent one was 70. Now, I can also tell that 48 and 52 were my two outliers. They're not grouped with the rest of the data. I also had a very high column here on 80. I'm kind of curious if those were the true answers or just made up answers. That's what I'm wondering about. Um, but anyway, so my majority of the data is here between about 59 and 80. Okay, so again, the advantages of the dot plot, no data points are lost. So even if I didn't have my original data, I could still figure out how many values of what kind did I had in my original data set. So that's the advantage of the dot plot, while you can still observe the shape of the distribution. And another advantage of the dot plot also, when you, just like with stem plots, if you want to compare two populations, you could do the dot plot for the second population beneath, under the number line, and basically compare your two populations that way. So advantages and disadvantages of stem plots and dot plots. Advantages: they're quick to do by hand, allow you to see the actual data values, allow to compare two populations side by side. Disadvantages: can be messy, especially if there is a lot of unique data values. Disadvantage number 2, only used for smallish data sets. You're not going to do them if you have, let's say, 1,000 of values to enter. Okay, so that concluded our stem plots and dot plots. Now the next graph that we're going to talk about is frequency polygon. Again, let me show how to do frequency polygon. In order to do frequency polygon, you would have to do the same work that you did for a histogram. You would have to group your data, um, find the frequencies of each group. But here, instead of doing bars like we did before, you would find the class midpoint and basically so your x coordinate would be your class midpoint and your y coordinate would be your frequency. So you would put those points on your graph and then connect them. And then once you ran out of classes on the left and on the right, you would pretend that you have one on the right with a frequency of 0 connected to 0, and do the same thing on this side, connected with 0. So that pink line is your frequency polygon. So again, basically plot your points where x coordinate is your class midpoint, y coordinate is frequency, and connect those dots. That's it for frequency polygon. So the next graph would be an ogive. But in order to graph an ogive, we're gonna calculate the cumulative frequency of each class. What is a cumulative frequency? That's when you add the frequencies as you move through your data. So the frequency of the first class was 2, so you're just gonna write 2. The frequency for the second class is 2, so you're going to add it to the frequency of the previous class, which is 4. So the cumulative frequency of the second class is 4. So basically, you're writing down here how many values you have from this point up. Okay, so in the next class, you have 16 frequencies, but above that class, you had 4 already. So it's going to be 16 plus 4 will be 20. Okay, and you continue doing that. So 44 values in this class, and above you had 20. So that's going to be 64. Okay, and then 11 plus 64 is 75, and 7 plus 75 will give you 82. Okay, so now remember, like with the frequency polygon, we graphed the class midpoint for the X value and the frequency for the Y value. For the odd drive, you do the same thing, but instead of frequency, your Y value is going to be cumulative frequency. So we're graphing points 51, 2, 57, 4, 63, 20, so forth, and connecting them. So again, my X values are going to be my heights, and the lowest is 51, and then the highest is 81. Make sure that you have it on your axes. And then for the cumulative frequencies for the Y values, I need all the values between 2 and 82. So yeah, it's a little bit, it's going to be compressed, but in order to fit everything on the screen, I had to do that. Okay, so the first point is 51, 2. So 51 is right here, and 2, this is 10, by the way. So 2 is somewhere here. That's going to be my first point. The next point is 57, 4. So and somewhere here. 63, 20. So 20 is right here. 63 is right here. The next point is 75, 75. So so no, this 60, 70, 75 is right here. And the next point is 81, 82. So 82, so this would be 90. So 82 would be like here, and 81 on the X right here. And then I'm gonna connect those points, and that will give me my ogive. So the ogive is basically tells you the story of how the data accumulates. So that's your cumulative frequency, and then you could actually divide it into percentiles, like so. Yeah, so for example, you could identify the middle data and see where's the lower 50%, upper 50%, so forth. All right, so that's the ogive. So the whole idea of visualizing data, we want to compare data, we want to compare to other data sets. And so in the next video, we're gonna talk about data shapes, which are obvious from our visual presentation of data. That's the whole point of it. So we'll see you in the next video.